Hello, good morning, everyone. Welcome to this 10th edition of our ECOSYSTEX Insights Series webinar series on the 13th of September. Thank you for joining us, to those who are here for the first time, but also, of course, a very warm welcome to those who regularly join us for our Insight series. At first, I would like to introduce myself. So my name is Tilla Cross and I'm Sustainability Programs Officer at Textile ETP. And we are responsible for managing this ECOSYSTEX community, of which you will hear 3 member projects present today. Textile ETP is an organization based in Brussels whose aim is to match textile and clothing related research and innovation with the European industry needs and priorities. And yeah, I'm happy to guide you through today's webinar. And whilst people arrive, I would like to remind you of our webinar procedures. So this webinar is recorded and will be shared on public channels. If you have questions throughout the webinar, please type them in the chat and we will address them in the time dedicated to the Q&A. If you would like to elaborate on a question, please raise your hand and then we will invite you to speak. This is the agenda of today. So first I will provide you with a short introduction into what ECOSYSTEX is in case you're joining for the first time. And then we will hear from the Live Treats project, followed by the Threading CO2 project, and then invite both of them into a Q&A session. And afterwards, we will follow up with the tExtended project and potentially the Star for BBS project and another Q&A. And towards the end, I will wrap up and provide you with an outlook on other interesting events that are upcoming in the next weeks and months. So some of you might already be familiar with what ECOSYSTEX is, or you're even a member of this community. Others that might hear about it for the first time, I would like to briefly present to you what ECOSYSTEX actually is. So ECOSYSTEX is the European Community of Practice for Sustainable Textile Ecosystem. And it was created with the goal in mind to create a permanent expert community and central knowledge hub for practical application of EU-funded science and technology for textile sustainability. So our community was founded in January 2023, and we grew to soon 40 member projects, which are all EU-funded projects with a focus on textile circularity and textile sustainability. Our activities are threefold. So for one, we want to foster inter-project collaboration by bringing together the knowledge and the experts from all across Europe, all working on related topics to textile sustainability. Then we also want to aim to enhance engagement with policymakers and support them in their decision and policy making by providing them with expert input. And our third objective is organizing dissemination activities like this webinar, where we ensure that an interested public outside the community can be informed about what is going on in the technical work of these projects. And here on the right of the slide, you can see just a couple of numbers. So we have over 280 registered experts from all across Europe, and they come together in 6 different working groups where this aforementioned inter-project collaboration takes place. Every other month, roughly, we organize these public webinars, and we also organize an annual conference that will actually take place next month. But yeah, here you can see all our member projects on one slide, and already highlighted are those that will present today. And with that being said, here you can see the agenda again, and now it's time for me to invite our first speaker on stage, Åsa Degerman from Södra Innovation. So please, I will stop sharing my screen and you can take the floor. Thank you.
Thank you so much. I will just sort out the...
It was the very last one. Helms, yes.
Thank you so much. I hope you can see my screen, and hopefully you can see a small part of me. But I'm Åsa. I work for Södra, which is a Swedish forest industry company owned by 52,000 family forestry. And I'm here to talk about the Life Treat project, which is a collaboration between Södra and the fiber maker company Lenzing. And I will give you a little bit of the background, why we started this project, and also I will give you a little bit about the strategy, but also the scope. So I have a couple of slides, and you also have here my contact details. So if you have any questions, just call me or send me an email, and I'm more than happy to take questions and discussions regarding how to improve the textile system and get full circularity. Life Treats is the abbreviation of textile recycling in Europe at scale. And here you have a very nice overview of our mill, the Södra pulp mill in southern part of Sweden. It's a huge mill where once more is the textile recycling part, and that is, if you can see my cursor, it's the once more plant is actually the facility down here. So today we have a recycling plant where we do chemical recycling of textile on a scale of 2,000 tons textile waste per year. And it's located here in the southern part of Sweden, quite close to Copenhagen, and also to a couple of hours away from Stockholm. So the background of the strategy, this is actually showing statistics from France and from Refashion, which is the producer organization that has been taking care of the textile collection and sorting in France since 2007 and 8. And it's a company or organization called Terra that do this sorting analysis and also the statistics. What is actually incoming streams of textiles every year in France. And you can see here on these statistics that it is a lot of cotton and polyester, both monostreams, but also mixed cotton and polyester, which is the big proportion of what is actually collected and sorted in France. Unfortunately, I do not have so much more data. I also have some data from Sweden, but it's actually resonates very well with the data from France, that what is collected is a lot of cotton and polyester. And that is the focus of the textile recycling within Life Treats, and with once more, that we close the loop for blended textile waste coming from cotton and polyester. So we can separate out the polyester and thereby actually improve the recycling rate of cotton. And we do recycle the cotton. The polyester is incinerated for heat recovery. So in a way it is recycled, but come back as energy. And we are feeding the plant in Mörrum, where I showed you before, with energy from the polyester. And then you have a small proportion on the left-hand side. It's also it's a lot of unknown material, but here you might have elastan, etc., but you also have the fossil-based polyamide and also wool, viscose, and acrylic. So the scope of textile of the project is about to increase and build a plant of 50,000 tons of textile waste. And I mentioned at the beginning that today we are at 2,000 tons, and we will then increase to 50,000 tons of textile waste. That mill and plant will have a capacity then of producing a little bit more than 60,000 tons of dissolving pulp. And dissolving pulp is the first step in producing viscose and lyocell and modal. So it's man-made cellulosic fibers. So we are the first step in the pulp making, and then it goes further to the fiber making, and that's why we have a close collaboration and have this project together with Lenzing, who's one of the main and key fiber producers in the world. Then after fiber, it becomes spinning, and it goes to the spinning process, and then it's dyeing garment, and then it will eventually come out in among the brands. So it's quite a long value chain, and we are the first one, or we can also say we are the last one if you now close the loop for the textile waste. Today we are at a recycling level of 20%, meaning that we take in the proportion in the mill is that we're taking 20% textile waste and 80% wood. And that's why we as a forest company is interested in this, because now we can produce with more resource efficiency. So we can close the loop for a lot of textile waste, and also increasing the value when it comes to the dissolving pulp, and we can do more, produce more from less with our forest. So that's the target is that we should go from 20% today to 50% recycled content. So 50% textile waste, 50% wood-based material in the future. And we think that that is, for us, a very good balance. And also it's important for us to keep the high quality dissolving pulp. So once more is a drop in product, meaning that if you have done or been using dissolving wood pulp 100% virgin before, you should have no difference in the production, and they should be interchangeable, the ones with recycled content, and have the same high level of standards and quality. So they should not be recognized as a new product when the fiber making or the spinner is producing with recycled content from once more. So that's important. That's why we are developing a lot of techniques. So the target is really to close the loop for post-consumer household goods. I mean, what we eventually have in our wardrobes and can no longer be circulated in the system as secondhand, because it's worn out and it's broken and can no longer be fixed. So the target is really to close the loop and recycle post-consumer household waste. That's the long-term ambition and target we have within once more. And then the second scope and target we have is that we should do this with reduced environmental impact. So already now we have conducted LCA, both for the phase 2, where we are right now by closing the loop for 2,000 tons of textile waste, but also for the future where we have the 50,000 tons. We have done simulation LCA in order to understand if we are meeting the target with reduced environmental impact, and we do. And we compare this with the generic viscose made in China, which is the benchmark and the standard right now. And we are also, the third target and scope is really to set up this textile waste supply strategy. And we're all here because we know that it's a very immature market. The infrastructure is not there. We've been recycling paper for more than 50 years, but we have today a rate less than 1% is actually fiber to fiber recycled when it comes to textiles, because there is the whole ecosystem and value chain is not in place yet. And we need also to create a demand, and we need to set new standards in terms of textile recycling in Europe and in the world. And I think we are together, we can only do this together. And I think we are now in the beginning, but we need to push in many different angles to make this happen. And a lot of innovation needs to happen as well, especially in the recycling part, material recycling part, but also in the sorting and creating new opportunities and business models, so we can get economy of scale in this. And talking about scale, the fourth target and scope in the project is really about creating and developing something that could be scalable, but also could be replicated elsewhere by someone else. So eventually we might end up with a concept that could be replicated as a brownfield for minimum, but hopefully also as a greenfield. But everything depends, of course, in the economy and also in the financial viability in the business models and the willingness to pay for recycled content. So I think I will stop there. Then I think I'm nearly done with my 15 minutes. So I'm happy to take more questions when we have the Q&A.
Great, thank you very much, Åsa. And as said before, exactly, please direct your questions to her in the chat, and then we will answer them live during the Q&A. And now it's time for Bruno Marengo from Fairbrics to take the floor.
Thank you, Tyler. Hello, everybody. So yeah, I have the pleasure to introduce threading CO2 to you guys. I will give you a bit of insights about us, but first, I'm head of business operation at Fairbrics. I'm basically in charge of development and partnerships. Before moving to green chemistry, I was working in very different fields, starting with corporate finance and then helping fashion brands to develop internationally, especially in China. And I joined Fairbrics a year ago to help them on their development. About Fairbrics, we were born in 2019, based on the technical work of our CTO, Taufik. Nowadays, we are 30, split between our R&D center in Paris and our pilot line in Antwerp. At the moment, the team is 95% scientific, even though we are moving more and more towards more generous recruitment. In terms of financial structure, we of course are helped by the threading CO2 project that I will introduce later, but also by classic private equity investors, including one VC fund from the UK and H&M as an industrial. We first did a proof of concept for them, and then they invested in the company. Moving towards threading CO2, basically the idea of threading CO2 from the start was to create a complete value chain from CO2 capture to fabrics and textile materials ready to operate and be put in the supply chain. So we start, for instance, for the CO2 capture with triple helix, based in Belgium as well. and towards the value chain, we go up to les tissages de Charlieu, based in Lyon, who help us in the spinning process. But a bit more about our IP and the way we change things. So we decided to attack the polyester specific market. At the moment, you may know that basically virgin polyester is made directly from fossil resources, be it oil or charcoal. What we change is the feedstock. Instead of using fossil resources, we use CO2. That's our IP. So with CO2 and hydrogen, we succeed to create exactly the same two chemicals than the petrochemical industry, and we obtain the exact same polyester pellets. They have the same stability, they have the same characteristics, and we can create exactly the same polyester yarns. This brings us to one of the main advantages of the technology. It's a drop-in technology. You can do basically exactly the same t-shirt the same way. Why we tackle the textile industry and the fashion industry to start with? Because we realize, as you know, that it's a very highly polluting industry. And in this industry, the raw materials are actually one of the main points of pollutions and emissions. So we decided to attack the market, and among the raw materials, PET is actually globally the main raw material. It accounts already for 60% of the global market, but 95% of the growth. It's basically very strongly pushed by the demand from developing countries. What is interesting about the technology could be summarized in three main aspects. First, obviously, we directly remove CO2 from industrial waste, for instance, and instead of just sequestrating it in the North Sea, we do something meaningful with it that could be used. Also, in terms of competitiveness, economical competitiveness, our first studies are very promising, and we think that within 5 years we will be competitive with the petrochemistry originated PET, and that's very important, obviously, because nobody will buy PET 10 times the price that it is at the moment. So it's really at the heart of the project. And finally, and that's also something that is really liked by our partners, is that our technology is easily scalable, because it's exactly the same pellets, exactly the same quality. So you just have to put the textile in the equipment already used, and you have exactly the same piece of materials. In terms of development, we have finished the lab part. We opened the pilot plant in Antwerp in 2023. We are actively working on it to optimize the production output of the pilot plant, but it should be 100% ready to operate in January 2025. We are already working on a demo plant that is part of the working package number 2 of our project. Our demo plant will be a way to demonstrate our ability to scale up our technology. We will have meaningful production capacity that will help us to showcase the technology and also do and propose commercial products to the market. At the end of the day, we are also thinking to move to a more licensing business model from 2029, 2030, because we really want our technology to be applied globally, and it's definitely the best way to have an impact on virgin PET producing, because it's easier and cheaper to retrofit existing factories than create new ones at the moment, especially in countries like China. A bit more about the people who are working with commercially. I mentioned H&M before. We are also working with On Running, Switzerland brand. We did this pair of shoes for them. We are also working with Aigle, with Citeo, with a packaging leader in France, and Forvia. So Forvia is also textile because they do, I think, 1/3 of the car seats in the world. And we are developing this kind of strategy of development as well with this kind of partners. We are working with them on multiple aspects, from the proof of concept to offtake agreement. Finally, to give you a bit more intel about what we are doing at the moment in the various aspects of the project, we are developing the number of partners, commercial partners we're working with. We hope to be able by 2025 to work with one to create our first commercial capsule collection. It's not going to be thousands of t-shirts, but it's going to be a couple. We are also working hard to sign offtake agreement for the future demo plant, because it's a good way to secure a future and also consolidate the trust the investors have in us. At the moment, one of the main focus for Trading CO2 is to recruit people. We recruited 12 people in 2024. We will recruit 15 in 2025. And the hard part for this is that we obviously recruit what we know how to recruit, meaning PhD scientists, but we also start recruiting finance manager, business developers, and it's a change for us, and it needs, it creates a need of a bit more explanation and patience. And finally, as I mentioned, we started already to work on the demo plant. It's the big project of the moment right now, with the difficulties that we are creating a factory, a plant that has never been created before. So we don't have a benchmark. So it's very intense engineering work, scientific work, and that really will be the focus for the next year and a half. And we really hope we can have all the bricks together before S2 2027. So yeah, that's it for me. I think I did it faster than expected, but happy to have your question, and you have my email address if you have a personal question. Question you don't want to ask in public.
Thank you very much, Bruno, for your interesting presentation. And indeed, please stick with us while we collect some questions for you. And I would also like to invite Åsa to join us here again, so we can kick off with the first Q&A. Great, there you are. So the first question to you by Pitusa Bulano was, which is the labeling requirements for recycled fiber composition?
Sorry, who the target? Was it for me or for both?
Yeah. No, sorry. That I think it came at a time that it was directed to you.
Okay, so we have recycled claim standard RCS certified, and then of course the forest is FSC and PEFC, but the recycled claim standard we are applying to.
Thanks. The second question is also directed to you, Åsa, by Lutz. What is the expected percentage of material processing loss in the scaled recycling plant? When 50 kilotons of cellulose-rich textile waste goes in, how much dissolving pulp comes out and how much dissolving pulp is lost in the fiber making process?
So we're talking about the yield here. Yeah, I would say that the yield is approximately 90%.
Then I'll go to a question to Bruno. Are you already able to provide polyester tops to make an industrial trial on spinning and weaving?
Yes. At the moment, we are able to provide around 20 kgs per month in the pilot line. So it's not a lot, but it's enough to do industrial trial, and that's what we do with already with our partners.
Thanks. And the second question to you was, can you say something about your energy input, please?
Yes, of course. So we use energy, obviously, to transform CO2 into the various monomers. Actually, the good thing with our technology is that we eat less in our various steps than the petrochemistry, and we obviously measure every steps in terms of LCA. So when we do both monomers with our technique, we have a carbon negative footprint. So we use energy, but we still decarbonize. I don't know if it replies the question, but it's also important for us, and that's one of the important part of our choice of plants localization, and that's also why we opened the pilot line in Antwerp, because obviously green energy is quite strong in Belgium already, and that's why we opened the pilot line there.
Interesting, thank you. I'll go back to Åsa with another question in the chat by Murao Bilela. I'm definitely pronouncing that wrong. The assumption is that the textile waste contains about 43% of cotton and 19% polyester. What is your threshold of cotton and polyester in the textile waste to be processed? Or maybe that's actually directed to Bruno. It doesn't.
It applies to me as well, I think.
Okay.
But I can start, but we take 70% cotton and 30% polyester. So minimum 70% cotton we need to do. That's the ratio, 70-30.
Thanks. Okay, let me check if there are other questions. Yes, there are a couple more for you, Bruno. So what is the source of the CO2?
So we actually are very lucky because we can use a lot of different sources of CO2. We made a lot of trials with, for instance, bio CO2 for methanization, but the ultimate target is, the target, and that's what we explore at the moment, is industrial waste. CO2 from the industry, and that's also why, for instance, it's nice to be in Antwerp for pilot line, because we can actually source the CO2 easily in the area.
Thanks.
That's the idea.
Can I ask a question then, Bruno? So it's like carbon capturing model.
We don't do the carbon capture. We are working with a partner in trading CO2, Triple Helix, also based in Belgium. The thing is, carbon capture, I mean, DAC basically technologies are developing very fast because they need to capture the CO2, the big industries. We kind of follow the same path. So we should be ready exactly at the same time. Yes, I mean, we are not involved directly in carbon capture, but that's something we are looking extremely closely because it's also one of the key point of the development of our technology.
Thanks. All right, there are 2 more questions in the chat for you, Bruno. So there is one saying, which post waste during your production process and their remediation?
So we have we have water waste. I mean, it's not big. It's we need to stabilize the water after the process. For instance, we use solvent in the process, but we use it, so we recycle it. Apart from that, to be completely transparent, I'm not the scientist part of Fairbrics, so there might be other ways, but I know the bigger one are water treatment that we need to apply after the process, and solvents that we use and recycle.
Thanks. And the last question that's currently in the chat, also directed to you, Bruno. Do you have a feedstock valorization process? Polyester types are varied and behave very differently in further processing.
So actually, we are working with. We actually doing the monomers, not the PET. So we are working with a partner in polymerization. Sorry, and depending on the client's request, we adapt exactly with that polymerization partner to the need they have. At the end of the day, Fairbrics is a chemistry company focusing on the textile industry, but we create chemical components and monomers that are highly adaptable to the needs of the client. We don't create one specific kind of polyester. We create monomers that can then be used to create various types of polyester. And actually, we realize that our technology is also can also be adapted to a lot of different subjects, and we did already in lab a couple of experiments, for instance, to produce green fuels or things like that. Of course, it's a completely different subject, but I just wanted to remind that we are focusing on the textile industry, but we are really at the beginning of the chain.
Cool.
So I know nothing about the quality of polyester. Sorry.
Well, thank you to both of you for your time in answering all these questions. At this point, there are no more questions. Maybe there are a few more coming in, but we will also share your presentations with the audience where they have your email address and can reach out to you should there be more questions. So thank you for that. And now it's time for me to invite our next speaker from the tExtended project to our virtual stage, Pirjo from VTT.
Hello.
Hi.
Let's just start sharing. Here we go. Can you see it now?
Yeah, perfect.
Okay, thank you. So hello everyone, I'm Pirjo Heikkilä. I'm working as a principal scientist and project manager at VTT Technical Research Center of Finland. And I'm happy to be coordinating the Extended project. So its full name is Knowledge-Based Framework for Extended Textile Circularity. Well, this project has been triggered by many things. It's very familiar to this group. So current system is textile system is not sustainable, and there are so many different technical and non-technological challenges that needs to be solved in order to be more sustainable and more circular. We know about separate collection, which has been started in some countries and will be starting in rest of the EU area in New Year, but in order to get then things running, there are so many things that needs to be developed related to identification and sorting and collecting and recycling, and also improve kind of other actions around that, including data sharing and digitalization that needs to be also needs a lot of development work. We acknowledge about textile materials to be mixed materials, blends, and having different components. And even though there are some examples, like we heard earlier today, that there are some solutions for blends, there are still so many other blends as well, and these laminated and other type of materials containing many things we still need to solve. And also currently in many cases, textiles are recycled in lower value applications. And that is not helping the situation that virgin textile raw materials are not very sustainable either, and we want to replace some of that with the secondary raw materials, so fiber to fiber recycling. Also the data sharing. The digital product passport is coming, but there are also so many other things in textile industry which can be improved if we share data, if we increase digitalization and have these new solutions going, that they are firstly these systems need to be developed, and secondly, we need to be able to motivate textile industry to participate this data sharing in order to get all benefit from that. Also, there is this regulatory framework, already mentioned textile separate collection, and we all know the textile strategy as well, highlighting higher quality textiles from secondary raw materials, and also all the innovations and this needed for competitiveness and resilient textile sector as well. But not going into details, but focus now more on what is our project. So this was twin transition goal. So we are looking on technologies as well as digital solutions needed. Also, we submitted our proposal in the call, which was generic waste call, so not specific to textiles, which was a little bit challenging, of course, but also very interesting experience. Our project is quite big. We have 20 partners in 10 countries, and kind of our total budget is over 15 million. We have one Swiss partner included, so either a little bit above or a little bit below 15 million, the overall budget, with EU contribution of 12 million, and duration is 4 years. Also, what can be mentioned here is that we have interesting kind of linkages with the Processes for Planet partnership. Now there is partnership also for textiles, but this is included in the Processes for Planet partnership. And through that, we are included not only ECOSYSTEX Eco, but also Hubs for Circularity community of practice. And we have to highlight industrial urban symbiosis, which is part of this strategic agenda of Processes for Planet partnership. Our partners are listed here, so in different parts of Europe, both from in research and industry, and then many partners who are supporting work, different ways of communication and that kind of activities. I have included description of the partners in the slide deck, which will be shared, and you can find information from our website. So I now focus more on the concept description. So the knowledge-based framework for extended textile circularity, what we mean by that. We have our aim is, overall target is to make this kind of master plan how more sustainable system can be built, kind of blueprint, and it is planning to kind of enhance both product cycles and material cycles, so reuse and recycling, and replacement of primary textile fibers and reducing the amount of waste. Kind of theoretical basis on that is this knowledge-based conceptual framework, which is determining optimal ways how to take different kind of textile flows or batches for the utilization. And in that work, we try to kind of keep value high, retain value, but also do it in safe and sustainable way. And when we have built our concept, it will be tested in a real scale demonstrator. So this was also the expectation coming from the call text. And we try to kind of show the potential how we can reduce textile waste by 80%, not within this project necessarily, but the potential, and also study replication potential of the system. It is reducing waste, increasing reuse, as well as material recycling. So another kind of more explaining our concept, first about other activities in the project. We are developing different development work, and impact generation is also carried out in order to do this. So we are creating systemic understanding about the sustainable and safe textile system. We are developing this knowledge-based and digitally enabled system here. So the different work packages are providing items to support this. And also there is a lot of development work carried out for textile recovery, so collecting, sorting, and reusing, as well as waste valorization and recycling, so technology development as well. Within this, I kind of, again, show how this blueprint and conceptual framework come in the picture. So we have a textile production of textile fibers, materials and products, use phase, and then for making it circular, it needs to be collected, sorted, and maybe pre-processed, valorized, and then recycled. Our blueprint is kind of looking what is different routes and helps routing these different kind of textiles in the system in the different levels, and then the conceptual framework is kind of this model which takes into account of the quality of materials, environmental, social issue, economics, and also different other requirements. So that is how we plan to optimize things. And a little illustration of how that works. If we have post-industrial waste, for example, cotton cutting clippings, it's quite kind of understandable that it can be chemically recycled, can be mechanically recycled. And it is also quite easily understandable that the most sustainable route is to go with fiber mechanically. It's good as new and easily for mechanically applied. However, if we, for example, do have polyester containing textile product, technically it can be reused or using in remanufacturing, mechanically, thermomechanically, chemically recycled. So technically there are different options but what is the optimal way? And there is where our conceptual framework come into picture. So it is a model and a tool. It looks, it calculates, it weights things related to sustainability and recyclability, recycling, economics, social aspects, logistics. So we are now building this kind of optimization tool, trying to get this more knowledge-based system. Our partners, like mentioned before, are located in different areas of Europe, and the real scale demonstrator where we apply our model is then carried out in collaboration with all the partners. And we use our tool for different industrial and urban textile flows. We then forward them in the reuse and recycling processes. And we generate the knowledge and demonstrate the solution needed for the circularity. And after that is carried out, the replication potential is then kind of studied in the more closed regions. So during our project, there will be a lot of new actors expected to start the business and development work outside of our consortium as well. So when we have carried out our demonstrator, we look, can this be done in the smaller areas with the other partners? So look what is happening also outside of our consortium. Our research work is divided in the 6 work packages. In addition to those, we have, of course, communication and management. We have a kind of theoretical work and practical development, experimental work, and then some engagement activities in here as well. One work package is focusing on this kind of looking on circular textile ecosystem now and in the future. And then there are 2 work packages, one focusing on the digital tools and technologies needed before our model is, the conceptual framework is applied, and another one on recycling and waste valorization technologies, so what is happening after applying of our tool. One work package is developing this textile waste classification tool and digital data sharing infrastructure. And in the demonstrator, we have planning phase, we have experimental phase, and this engagement involving replication potential study. Also, we have one work package dedicated for evaluating of our technologies and our demonstrator and looking on these barriers, what is preventing or hindering us for becoming more circular. And then again, in the work package 1, which is looking on system as a whole, we will generate a vision for this kind of hub for circularity for the future. We are expected to kind of generate impact for this from the knowledge-based and digitally enabled system. One pathway for impact is the recovery part, another recycling, waste valorization recycling, and then also this systemic understanding. And we have identified a lot of key exploitable results coming from these different impact pathways. And expected impact, we are expecting to have scientific advances, societal impacts, economic and technological, of course, and environment. So is that, and where we are now, we have now just kind of submitted our first periodic report. We have started our project and make some proof of concept of our technologies, first in lab scale and continue development, and also made the vision for the future. Now we are in this stage, we have started the preparation for the demonstrator, so planning of it has been started. We still have more than 2 years to go until the end of the project. In the slides, you can find our communication channels. But I also want to kind of highlight that we have community of practitioners. We want to be involved with our stakeholder, other organizations and projects, and this is open for any one of you to join. It's a very low threshold opportunity for collaborate, and we have been now planning to have our first community event in later this autumn. And this is guidance how to join. There is a link or also QR code for you to find the possibilities how to join. But maybe that's all for now. Thank you.
Thank you very much, Pirjo, for sharing the tExtended project developments, and we'll make sure to invite you again to join us in the next 2 years for sure. For now, while we're collecting for you questions in the chat, I would like to invite our last speaker of today, Nikola from the Technische Universität Berlin, to present us the STARFO BBS project. Let's see.
Thank you, Tila. I will now present my screen.
Perfect.
I hope you can see it in full mode.
Yes, looks good.
Thank you. So I will start by introducing myself. Sorry that my name sounds a bit weird here in the Teams. It's because of the technical glitch. But my name is Nikola Matović, and I come from the Technical University of Berlin. Together with my colleague, Dr. Rulana Ladu, we are leading the STARFO BBS project. And today's presentation is called Sustainable Bio-Based Systems through Effective Certification and Labeling. I'll start by actually introducing the project. STARFO BBS stands for Sustainability Transition Assessment Rules for Bio-Based Systems. This project is part of a Horizon Europe call, and it's running from September 2022 to August 2025. So the main goal of the project is actually to maximize the potential of sustainability certification schemes and labels to support transition to a sustainable bio-based economy. Currently, one of the key issues, as you all know, is the lack of transparency and harmonization in certification schemes, which makes it difficult for consumers to compare sustainable products and actually assess their sustainability. This challenge is even more relevant in the context of the Green Claims Directive, which aims to establish common criteria to prevent greenwashing and also misleading environmental claims. STARFO BBS brings together a multidisciplinary team of 7 partners, 3 associated partners, and 1 linked third party across Europe, as you can see on the right-hand side. And our mission is to assess the effectiveness, robustness, and credibility of these certification schemes and labels to ultimately contribute to more transparent and more trustworthy sustainability systems in the bio-based sector. So we have 8 objectives of the project, and the first one was to actually gain a more comprehensive understanding of the current landscape in the international and EU schemes and labels for both biological feedstocks and bio-based materials. So within this task, we reviewed more than 100 schemes and labels and more than 5 monitoring systems dealing with bio-based products and materials. Our second objective was to evaluate the global trade data on certified and uncertified flows of biological feedstocks and materials. The third one was focused on the exploring of the impacts of schemes and labels on sustainability, while the fourth one is tied to the fifth one, and it focuses on firstly identification of key indicators and metrics to be included in the monitoring system. A monitoring system is actually a development of a benchmarking tool for which we joined forces with 2 sister projects financed under the same call. I will talk about this a bit later. So we developed a joint monitoring system that would assess the effectiveness and robustness of these schemes and labels. And this system is being pilot tested and validated by the stakeholders. Using the monitoring system, we applied by assessing and ranking at least 50 schemes and labels in our project. Within the 7th objective, we evaluated the costs and benefits of adopting these schemes and labels in specific value chains. And finally, we aim to maximize the relevance and uptake of the project findings by engaging a wide range of stakeholders. And currently, we are in the 3rd project year. So when we talk about the development of the bio-based cert monitoring system, or the BMS, as we shortly call it, there are 2 key aspects we need to consider. What is the purpose of the BMS? Our purpose is to actually increase the understanding of how these effective and robust certification schemes and labels are currently in the European market for the bio-based systems. Our system should also provide a framework for the European Commission and also schemes and labels owners to evaluate how well these schemes actually contribute to sustainability goals, especially when we're talking about SDGs. So importantly, BMS also aims to facilitate the harmonization of the sustainability and governance criteria, which are often inconsistent across different schemes and labels. Our 2 main audiences, as you can see on the slide, are European Commission or policymakers and also certification schemes and label owners, and they have different reasons to benefit from the BMS. So when we say bio-based systems, what actual products are we looking at? So we are looking at schemes and labels who are intended for industrial bio-based value chains and to bio-based materials and products, excluding, and this was excluded also from the Horizon call. So we are not looking at those for the food, feed, recreation, and bioenergy and biofuel. As for the depth, we are considering entire value chains. We are trying to capture all aspects of products life cycle, and geography-wise, we are mostly looking at the products that are produced and traded, so meaning imported and exported to EU, within the EU. But also because most of the feedstocks that are quite important for the market come from other countries, 3rd countries, we are also looking at those geographical regions, and we are having them considered. Regarding the bio-based cert monitoring system itself, we have 3 main levels or functions, which we wanted to let's say, emphasize this way because most of the tools so far have looked at the content level, at this just sustainability content of the schemes and labels. But for us, the backbone is this function 1 of the system level, which looks at improving acceptance of the stakeholders by building trust and transparency, and includes different credibility indicators, credibility governance indicators that you will see later. The content level is the cruise of the system and includes, besides 3 very known pillars, environmental, social, and economic, also circular. And the outcomes level, which tries to capture the effectiveness and impact of schemes and labels, mostly on social and environmental aspects. Besides these 3 vertical, we also have horizontal layer, which is actually interpretation or evaluation mechanism. This is how we are going to address and assess and also visualize our results in terms of evaluation of the schemes and labels. So now I will just present shortly these 3 levels within our BMS, with our tool. So here you can actually see that each of these 3 levels actually contain some kind of principles. First of all, we have 4 identified and developed categories within the BMS system level. Those are governance and scheme management, standard setting, assurance, and traceability and claims. And each of these 4 categories or key areas contains different principles with a number of lower tier elements, so criteria and requirements, which are all fed into specific database, which we actually use for the testing. And here on the next slide, you can see how they are actually distributed in this classification on the left-hand side. And on the right-hand side, their distribution of criteria across these 4 categories and also the principles across the categories. But I have to say that these numbers within our project, as it is still ongoing, and the testing is also the second phase of testing ongoing. We are having changes as we speak because we are constantly seeking for the feedback from the testers, from the stakeholders, including CSL owners, which schemes and labels are being tested, and also, of course, broader stakeholder categories. And this is how the indicators actually look in our database. And this is example from the assurance category. We have different columns with different functions, as you can see here. And for example, this criterion is also kind of an indicator for the auditing principle, which looks at the types of activities that conformity assessment bodies are required to, for example, undertake during a full audit. And this is also just a glimpse of an evaluation structure and some kind of compulsory requirements that we identified within each criteria. And we actually have also scoring system here to then evaluate and see where the schemes or labels can be improved. And this is also a visualization of results using spider diagrams for all these 4 categories. And you can see like the principles here. This is just a dummy example, but this is how it will look like in the end. And also overall principles for one specific scheme or label and their assessment results. Here you can also see how this looks for the content level, actually what principles or key areas are within each of these 4 dimensions. And we try to actually make it as concise as possible, but you can see here that currently we have almost 400 different indicators, which we considered important for the bio-based sector within these 4 pillars, and also minimum backstop, which is compliance with legislations. And of course, for the final function 3 or the outcome level, we also want to emphasize that this level is mostly unrecognized. Sometimes it is within the schemes and labels, of course, currently. Sometimes it is part of the system level in some schemes, but also some monitoring tools, or in different parts of also content level contain some kind of principles and criteria for the outcome level, but we wanted to make it more important as, of course, the relevance experts and academia have found that it should be also emphasized, and like the long-term continuous improvement of the schemes and also monitoring and evaluation. Most of you are from the textile sector, so I just wanted also to briefly emphasize what we are doing for the textile sector. So we have, for example, selected the value chains. From before, you know that we have selected some bio-based value chains, and as well as products and the feedstock. We have the cotton as well as t-shirts made of cotton. So for this reason, and because better cotton is one of the schemes from the second testing phase, currently being evaluated, because at the moment we are benchmarking the indicators from the bio-based threat monitoring system with a selected number of sustainable schemes and labels. Better cotton from the textile sector, we are actually now just starting with it, because a few days ago we had a meeting with the schemes and labels being tested now. And we will actually look at the better cotton's procedural documents first. As you can see in the step 1, we are selecting all the relevant documents for the system level, for which we are leading from the SARFO BBS. The other 2 projects are leading content and the outcome level. We are looking at operational requirements of the better cotton, and we're going to review and analyze documents, of course, in close communication with the better cotton, because except from some procedural documents like the excerpt being seen here, we also need to check if to see the validation of our results, first by scheme and also by internal and external experts that we have within these 3 cluster project teams. And this is to actually assess how better cotton will comply with the criteria and indicators laid out in our monitoring system. Also important in the textile sector sense, we have Textile Exchange that plays a key advisory role in the Start for BBS project as a part of the Joint Advisory Board, where we use their expertise to also guide our assessments. One of the main tools from the Textile Exchange, the Preferred Fiber and Materials Matrix, which I guess some of you have heard of, provides actually a detailed understanding of sustainable practices across various material categories. And this tool also evaluates certification schemes or standards based on a wide range of around 80 qualitative and quantitative indicators. And it covers different kind of impact areas, but also you have to know that it actually contains like system content and level system content and outcome level indicators like we do in our scheme. And those include also climate, water, chemical management, standard setting, monitoring, evaluation, and so on. So for us, this is crucial that we also apply some of the indicators that I have within this matrix for the bio-based threat monitoring system to also identify maybe some critical sustainability criteria for feedstocks, such as cotton that is used in textile industry, to allow us actually to benchmark our BMS against recognized standards. And finally, you can also follow us if you're interested to learn more about our project. And you can also join, of course, our community, and we are happy to share the news of the progress with you. Thank you for your attention, and I'm open for any questions.
Thank you very much, Nikola, for your interesting presentation. And as we start collecting questions for you, I would like to invite Pirjo back on stage. Yes, I can already see you. There were a couple of questions for you in the chat, and just to make sure that also those that watch the recording afterwards, I thought I'll still ask them to you in person, so we can have the answers recorded as well, if that's okay for you. So the first question was, in your circularity, do you include the textile effluent and dyes treatment, or are you only dealing with solid waste?
Yes, so we are studying removal of dyes from textiles, but we are not focusing on the treatment of wastewaters, any effluents or wastewaters.
Thanks. And second question to you was, are you also looking at textiles with different fabric finishes, such as flame retardants, water repellent treatments, coatings, etc.?
Yeah, I didn't answer that by writing because it's not that simple question. So we have acknowledged that there are finishes which might affect what is the possible use for the routing of the textiles. So some of the finishes might be not suitable for skin contact products, for example. So some fire retardants used in the interior textiles cannot be kind of forward in the clothing application. So yes, we are looking at aspects from the finishes, but we are not having any kind of processes for removal of finishes at the moment. So dyes are included, but there are no activities to kind of widely study removal of finishing agents. However, coatings are another thing. So we are looking how we can separate certain type of coatings from the textiles so that we can then recycle fibers. So yeah, yes, we are looking them, but not developing solutions for all types of finishes. So very complicated area, and I think there are some projects fully focusing on the finishes as well. So this is a very big research area.
Thanks for your answer. And there was a third question to you, Pirjo, about your community of practitioners, if you have specific criteria to get collaborators on board or not.
Yeah, that group has no specific criteria. So anyone are are kind of welcome, and there might be certain activities in the future for if we need, for example, feedback, make interviews, or having some very specific workshop on certain topics where we won't like to have kind of views from experts outside of our consortium. So you might have some type of deeper collaboration with certain type of stakeholders, but our community of practitioners is open for anyone, and there we have events where we tell our results. We might collect some feedback from them, but yeah, there might be. Please join that and listen more about any coming more deeper collaboration activities as well.
Thanks, Pirjo. And so we're coming more towards the end of our Q&A. If you have any question for the staff for PBS project, you're more than welcome to still drop them in the chat. And otherwise, I'm sure you can also reach out to Nikola directly when we share the presentation, because it is a very detailed field. So maybe you still need some more time to process everything, which is also totally fine. So for now, if there are no more questions coming in, I'll keep an eye on the chat, but we'll start sharing my final slides with you. And first, maybe I should say to our last two speakers, thank you very much for your presentations and staying with us here in this webinar and taking the time, of course. And here you can see upcoming activities and events from the ECOSYSTEX community. So at the beginning, I briefly mentioned that we organize an annual conference and that the second one will take place in October in Milan. And unfortunately, our on-site registrations are already closed, but we will try to offer as many sessions as possible in hybrid format. And my colleague Charlotte will drop a link in the chat where you can register to get the latest information, which sessions will be offered in hybrid and when, and then also receive the access link. And then we also have already scheduled the next two Insight series. The one on the 8th of November will be a very special one because it will be the first time that actually two of our technical working groups, the Technical Working Group 2 on assessment of different recycling technologies and end-of-life options, will present what they've been collectively working on in the past months, and also our Technical Group 4 on renewable materials and standards will do the same and present what they've been discussing and working on. So we will open registrations for that webinar very soon, and you'll receive an email from us with all the information. And the same goes for our next Insight series on the 29th of November. I would also like to point out these two ECOSYSTEX member project events that are upcoming. One is for the SUS-track pathway to design the circular bio-based transition webinar. I think someone from the project already dropped the link in the chat to register, which is great. And then we also have our members SCIRT organizing a webinar on research on chemicals of concern with the research organization VTO. And finally, I would like to point you to our Circular and Bio-Based Innovation Hub that we here at Textile ETP are founded and are organizing. And there we bring together European textile sustainability experts to learn, network, and collaborate on the hot topics of circular and bio-based textiles, and organize monthly learning webinars, have different formats to collaborate online with other experts from across Europe, and invite experts to provide their knowledge to you. And you will also have a link in the chat to learn more about that. And with that, we're coming towards the end of our webinar, a little early, but I'm pretty sure no one will mind that. If you don't follow us on LinkedIn yet, of course, you're very welcome to do so. And should you be part of a EU-funded project that works on textile sustainability and circularity, you're of course more than welcome to join the ECOSYSTEX community. And yeah, with that being said, I would like to say again, thank you to all our 4 speakers and also to you, our audience. Thank you for all your questions, and we hope to see you online again soon. Thank you.